Welcome to Ask and Learn.
So in this problem, we're given basically a piece of equipment, um, machine, that is supported by some springs, just like this. So we have actually 4 springs down here, but I'm only going to show 2 of them. Um, so we want to figure out the natural period of vertical vibration. So the center of mass of this is at the center. This problem is this oddly trivial, but anyway, so the kinetic energy of this is 1/2 m y dot squared, where y is the vertical velocity. The potential energy is just in the springs, although I guess we could add plus mgy, and then that would give us mg here, but that's not going to affect the natural frequency. It's just going to offset where we measure from. So if we measure this y from the static equilibrium, then this would go away. If we measure it from when the springs are compressed, then this comes in, and then our solution here would have a constant term that would just be the static deflection. That would just be, y constant would be mg over 4k, the static value. Anyway, that won't change the natural frequency. So since we have four springs, we have 4k y squared, and then saying the energy is conserved gives us this, which means our natural frequency is 2 times the square root of k over m, which means the period of the natural period is pi times the square root of m over k, and that is simply the answer, as we were not given values for either of these things. Now, this problem also, you could think about it, this thing could be oscillating back and forth, rocking, but they didn't ask us that just for the vertical vibration. And in fact, we could, if the vertical and the rocking motion actually could be coupled. I think they wouldn't be in this case, just because the center of mass is right at the center. But again, that would be a much more difficult problem if they were coupled together, and we couldn't just look at the vertical motion independently of the rocking motion.